All right, welcome back, forensic students. We are moving through our fibers section of our forensic evidence unit, and today we're focusing on fiber analysis and how fibers can be useful to a forensic investigator. As always, feel free to pause the video as needed. Now, we have learned about different types of fibers and how they're classified. So in the previous lesson, we learned that we have two classifications for fibers. We have natural fibers and synthetic fibers. And we talked about some different characteristics of each of those. Today, in this lesson, we're going to learn how investigators use those fibers to solve crimes. Now, fiber evidence is not one of the more common pieces of evidence found at a crime scene, but nonetheless, it can be an invaluable tool in helping to solve crimes. So, fibers can reveal critical information about and connections between suspects and victims and their environment. And fibers can come from a multitude of different places. So, clothing and carpet, furniture, curtains, bedding, insulation, rope. Now, since fiber evidence isn't specific to an individual or source, we classify it as class evidence. Furthermore, fiber evidence can also be classified as either biological evidence or physical evidence, but this is dependent on the type of fiber that's found. So again, in the last lesson, we learned that we have synthetic fibers and natural fibers. Synthetic fibers are man-made, and so synthetic fibers are considered physical evidence. Now, natural fibers, since they're derived from plants, animals, or minerals, these fibers are going to be classified as biological evidence. When fibers are found at a crime scene, it's important to be very accurate in recording the location of the fiber evidence. And there are different ways that investigators can collect fiber evidence. So some of those ways might be adhesives or forceps, which are similar to tweezers. Even vacuums. So investigators can vacuum a large area in hopes that they collect fibers that they can use to analyze. Fibers can be collected at crime scenes, but they also can be collected in the laboratory and even during an autopsy. Now, the first task in fiber analysis is to identify the fiber and its characteristics. So essentially, an investigator wants to determine what type of fiber they're working with in hopes that they can match it to a source or a point of origin. So next, the investigator is going to attempt to match that fiber to a suspect or source, either the suspect's home or car or clothing. And if you'll remember from Unit 1, we talked about Locard's exchange principle, which basically says every contact leaves a trace. And what that means is if somebody commits a crime, they are likely to leave behind trace evidence at the crime scene or even pick up evidence from the crime scene. And so using that principle, Locard's exchange principle, this is very helpful when looking into fiber evidence. So fibers often fall off and are picked up during normal activities. The same is true of crime scenes. Now, very small fibers easily shed from most textiles and can become trace evidence. And fiber evaluation can show things like type of fiber, color, the possibility of violence, location of suspects, and ultimately point of origin. Now, there's different ways that fibers can be transferred, and so it's important that you know you can have direct transfer. You can also have secondary transfer. So in direct transfer, fibers can easily be transferred directly from a victim to a suspect or vice versa. So an example would be a jacket fiber from a suspect is transferred to the body of a victim. Now we can take that one step further and add an additional transfer, and that would be called a secondary transfer. And in a secondary transfer, fibers are going to be transferred from a source to a suspect and then to a victim, or maybe from a source to a victim and then to a suspect. So an example would be carpet fibers from a suspect's house is transferred to the suspect, who then might transfer those fibers to a victim or to the victim's clothing. Now, there are different ways that fibers are tested, and so investigators are going to first try to identify fibers' characteristics by looking at it under a microscope. These are not going to be basic microscopes, though. These are pretty high-tech pieces of equipment that they're working with. But lab analysts are going to make observations about the color, the texture, the diameter, the shape pattern, and even the cross-section appearance of these fibers. Now, if there isn't enough fiber evidence present, investigators are going to use what's called a non-destructive test or non-destructive technique to analyze and view these fibers. So they'll use something like polarizing light microscopy or infrared spectroscopy to view those fibers. There are some newer non-destructive techniques that I listed on the screen. So one of those is MSP, that combines microscopy and with UV light. And that is great for very, very small samples of fibers. There's also another non-destructive test being used. It's newer to the field. It's called FTIR. It uses wavelengths of light to identify different molecular groups that are found within the fiber. Microscopy and spectroscopy were both used in the Atlanta child murders case. So if you're in my class, we're actually going to look into that case study in the future. But if you are not familiar with that case, you might want to look it up because it's very interesting. They used these non-destructive methods to identify fibers found at the crime scene and ultimately match these fibers from the victims to the suspect's home. Now, if there is enough fiber evidence present, investigators can do what's called a fiber burn analysis. And now this is a destructive test. Basically, investigators will burn a fiber and they will note characteristics of the fiber as it burns. They'll use a dichotomous key to ultimately identify the fiber. So fibers, when they burn, are pretty predictable. Synthetic fibers tend to melt when they approach a flame. After they burn, after they melt, they solidify when cooled. So synthetic fibers do not form an ash after they burn. They form like a hard plastic piece. When synthetic fibers burn, you know it because they give off a pretty strong chemical odor. If you've ever smelled like a burning tire, that's the odor. It's very strong. Now, I do want to note that the fiber burn test is a simple way to identify whether a fabric is made from natural or synthetic fibers. However, the test is definitely not foolproof. It can be affected by tons of different things, such as blends of fibers. Natural fibers burn in a pretty predictable way too. So these fibers, they don't shrink when they approach a flame. They catch on fire and they burn pretty quickly. Natural fibers burn to ash, so when they're finished burning, they create ashes, which are brittle. They smell like burning wood. So when natural fibers burn, it smells like a campfire. If you're not familiar with a dichotomous key, I wanted to show you one. I put this one on the screen. If you're in my class, we're actually going to do a fiber burn analysis lab where I give you some unknown fibers. We're going to catch them on fire and we're going to use a dichotomous key to match the burn characteristics to the identity of the fiber. But if you're watching this online and you're not in class, this is an example of a dichotomous key. So you can see here that we would burn the fibers and just sort of work through this key to identify what fiber we are burning. All right, that ends our lesson for those of you that are watching from home, and I will see you in the next lesson.